Hello friends, welcome to my YouTube channel. My name is Prathamesh. Without wasting our time, let's begin. And if you like, please like, share and subscribe. Today, we will deep dive in ChatGPT Image Creation 2.0 model.
Between 2023 and 2025, early AI models produced hyper-detailed cinematic visuals that appeared flawless at first glance, but closer inspection revealed a persistent flaw. Storefronts and street signs were filled with alien, mangled symbols where legible words should have been. These models lacked a structural understanding of language. They treated typography as abstract texture, attempting to replicate the visual curves of letters based on probability rather than reading the characters. This approach failed entirely when faced with complex non-Latin scripts. In languages with specific typographic rules, like Japanese, Korean, Chinese, Hindi, and Bengali, the AI produced little more than visual static. Because these early engines were built for mimicry rather than comprehension, they remained impractical for localized graphic design or global commercial use. This technical limitation changed on April 21, 2026, with the release of OpenAI's ChatGPT Images 2.0. This update replaced the previous text rendering engine with a system built to process visual language through a different logic. This critical launch marks the point where generative models began incorporating problem-solving logic into the image creation process. To achieve this accuracy, the model utilizes a specific reasoning engine. The process begins here. The model branches out to search the web, mapping specific typographic characteristics of global languages in real time. Before the final pixels are generated, the system compares its work against retrieved data, creating an internal loop of comparison and error correction. This self-verification step ensures that final outputs maintain correct spelling and natural, human-readable spacing. Without this internal proofreader, consistent typographic fidelity in complex scripts is mathematically improbable. The resulting text is not a simple graphical layer applied to the top of an image. Instead, the reasoning engine calculates the physical variables of the environment, including lighting, perspective, and the texture of the underlying material. We see this in how a Korean neon sign distorts in a wet puddle while maintaining the specific, legible characters of the original script. For the text to look correct, the AI must treat language as a three-dimensional object that reacts to its surroundings. The capabilities of the reasoning engine extend beyond just correcting letters. The same self-verification loop that fixes typography is also used to maintain visual continuity. The system can now track and maintain the appearance of characters or objects across up to 8 distinct images generated from a single prompt. In previous versions, small details would drift or mutate with every new generation, making sequential storytelling impossible. By locking in these details through reasoning, the tool moves from generating single snapshots to creating cohesive visual narratives. These technical improvements have changed the practical landscape for professional designers. Designers previously had to spend hours manually removing and replacing garbled AI text with high-resolution assets. The current model allows for the immediate generation of localized mockups and multi-image campaigns that are ready for review without manual reconstruction. By automating the verification of global scripts, the engine significantly reduces the time and cost required for professional-grade commercial design. Looking at the broader timeline of AI development, ChatGPT Images 2.0 represents a shift in the standard for accuracy. The model functions as a design assistant that understands the technical and cultural nuances of the text it generates. With reasoning and verification, the system achieves a precision matching global typographic standards. Look at how this character maintains their identity while shifting environments, from a futuristic street in Tokyo to a marketplace in India. Historically, AI generators struggled with text, producing the mutated scribbles you see on the left. On the right, we see the current state of the technology, precise Japanese characters integrated directly into the environment. The release of ChatGPT Images 2.0 introduces specific rendering upgrades for complex scripts, including Japanese and Korean, Chinese and Hindi, as well as Bengali. To turn these raw images into a marketing campaign, we need a repeatable workflow. We'll start by setting a visual baseline, then move into generating localized text, enforcing character consistency, and using automated verification. Solving the problem of non-Latin text allows us to use AI for systematic, localized asset generation rather than just one-off illustrations. Step 1 is defining the core subject of our campaign within the ChatGPT interface. We will start by prompting the model to create our brand mascot, a Cyberpunk Barista. To help the AI track this character across different scenes, we must include highly distinct visual markers, such as a bright yellow beanie and a glowing neon coffee cup. These specific details act as data reference points. The AI uses the beanie and the cup to anchor the character's identity when we change the background or the language. A hyper-specific baseline image is the prerequisite for keeping a brand consistent throughout an automated campaign. With the character established, we can now place our barista into a Tokyo subway station. We instruct the AI to generate the phrase "future brew" in Japanese, specifically asking for it to appear on a background billboard. This diagram shows the model's visual language fidelity. It isn't just generating shapes, it replicates specific typographic flow and vertical layout. Notice how spacing adjusts. The model calculates character density using grammatical rules to keep the columns balanced. The text also respects the perspective of the subway station, aligning with the vanishing points and interacting with the ambient neon lighting. Because the text is an organic part of the world's lighting and geometry, it avoids the pasted-on look of traditional AI text overlays. Now, we'll expand the campaign to India. We want the AI to retain our barista while generating 4 new posters. We instruct the model to render the phrase "freshly brewed" in Hindi, this time placing it directly on the character's apron. The continuity engine locks the barista's features in a central memory hub. It then projects those features into new frames while the environment around them changes. However, there is a technical limit. The model can only sustain this specific memory loop for a maximum of 8 images in a single chain. If you try to generate a 9th image, the connection to the original data points breaks, leading to visual mutations and character drift. Respecting this 8-image limit is the key to maintaining a cohesive look across a scaled campaign. Scripts with complex structural rules, like Hindi and Bengali, are prone to spelling hallucinations in AI models. To counter this, version 2.0 includes a reasoning feature, acting as an automated quality control layer. By adding a specific instruction to the prompt, we force the model to search the web and verify spelling before finalizing the image. The model checks the script against language rules in real time, correcting typographic errors during the generation process. This self-correction process helps ensure that complex characters are rendered accurately, reducing the need for manual design fixes. Here is the final result, a grid of consistent marketing assets localized for multiple regions and languages. We achieved this through 3 pillars: specific baseline markers, the 8-image continuity rule, and the reasoning protocol for script verification. Now, try applying this workflow to a marketing phrase in your own native language. The barrier between English-centric design and global marketing has narrowed. We now have a repeatable path for reaching international